E-kit is an ABB electrification solution developed from ABB Motion AC500 product, which provides an application layer enabling ABB devices and third-party devices to be integrated. Using E-kit, a device can be integrated by setting a model, allowing E-kit to interpret incoming data from that device correctly. Model creation starts from a generic template, which includes the main measurements managed by a family of devices, such as circuit breakers, meters, relays, and analog inputs and outputs. E-kit enables several devices to be integrated by means of the Modbus RTU and Modbus TCP/IP protocols. E-kit integrates up to 45 devices, up to 15 devices connected via Modbus RTU, and up to 30 devices connected via Ethernet network. Here is the setup for this demo. Here is the E-kit. Here we have an Emax2, and this is a third-party meters, Carlo Gavazzi, and we will provision all these devices using ABB Edge Industrial Gateway. Here is the E-kit. This is the CPU, and this is the SD card, which can be used for updating the application layer or backup of the templates, as we explained to you later. Here we have the supply port. Here we have the communication RTU port. These two are Ethernet interfaces port, which functions as switch. We can start configuring the E-kit by using ABB E-kit Connect, and we can go here and then selecting from this menu the E-kit. This is the communication protocol. Here we have to insert the correct IP address. Remember, before doing that all the devices should be on the same network, so basically all the devices should have the IP address in the same range. Here, as you can see, we can notice that E-kit Connect has opened the web browser interface of the E-kit, where we can start configuring all devices that we have. Basically, in this user interface, we can have two types of access. One is the guest, and the other one is the admin. With the guest, the user can only see data coming from the devices in the network. Instead, with the admin login, the user can also configure new devices. After the user has been logged in with the admin access, then he can start to configuring the devices, and we can go there, which is the access to the model database. And if he wants starting to create a model from a template, then he has to click on new from template. Instead, if he wants start creating a new model from a model, then he has to click on new from selected. And here are all the list of our templates. So for example, here we have the breaker and the vendor is ABB, and then we have the models already included in the database, and the user can select among these different models. Since we are using an ABB device, which is the Emax2, and we have already the model in place, then we can start the configuration, clicking here, and then we can choose a name for our device. Select yes, since the device is used. The type of communication, we can select the template, and then we have to choose among these models. Okay, you have to add the IP address. Okay, and this is the default TCP port. Then go to save and initialize. This green LED means that the device is connected, and here we can see the measurements coming from the device. Now we are going to integrate a third-party device, which is the meter Carlo Gavazzi, and since this is not present in the library, we have to choose from the template. So we have to select here the meter, and then since we want to modify directly the template, we have to choose a new front template. Here we have our model configuration. We can assign a name. We can start configuring the device, choosing the name. This is used. The type of communication is RTU. We have then to select the template, which is a meter, and the vendor is not ABB, so we have to select the user since we are using a custom model. This is the model, and then we have to provide the slave ID, which is 138, and then save and initialize. Once we have created the model, then we have to configure it, enabling or disabling the channel needed. And for example, we can select if the channel is used or not, and which type of channel it is. If the data comes from the device, then we have to select Modbus. If the data comes from the user, then we can select user, and then we have to select the access to this data, if it is a read or write, and the addressing, the type of register, and the number of the register, and the type of the data. To do this action, the user has to look into the Modbus map of the device and then set up all the items needed. And then the user can also add a normalization bit mask if needed, a shift, then a numerator or denominator in case the data needs to be scaled up, and an offset. To configure Modbus target data, the user has to check on the Modbus map of the device. For example, in this case, for the current L1, we can notice that this is the type of the data format, and this is the address. We have to compile this data. Okay, this is an integer, and the holding register, a read, and we have the normalization denominator. Then, since the meter is monophase, we can avoid to complete this one, and then go to the total active power. From the Modbus, we can notice that the total active power is this one. So this is an integer 32, and this is the register, and this is the multiplier. So we can set the configuration. So this is an holding, an integer 32, and the address is the 40, and the multiplier is 10 at the denominator. Once we have configured all the channel useful for the device, then we can proceed clicking on the save. Okay, then close, configuration, then save and reload to upload the configuration that we have done so far. Here we can see data coming from the devices. From data of type user, the user can directly editing here, by clicking there, and also for the serial number. And here is a third-party device meter configured. For RTU communication, keep in mind that the E-kit baud rate is 9600 bits per second, and the parity is even, and 8 data bit and 1 stop bit. To save all the configuration you have done in this section, you can go there and then save the settings. Moreover, if you want to save your models, you can have a backup on the SD, and you have to insert the SD card in the E-kit and then click on backup to SD, so that you can also transfer these models to another kit. Now we will show you how to provision these devices on the cloud using the Edge Industrial Gateway. We have already configured it so they are all on the same network and able to send data to the cloud, so we can start the provisioning. We have to select our ABB Edge Industrial Gateway. Here we have to make sure that our network is configured in the right way. And so basically we have to check the connection via ETH0 and the other device that are connected via ETH1. All local devices must have a static IP address. Before starting the discovery, take note of the code on the side of the device. We can select manual discovery and then add the IP address of the gateway. Add the code of the gateway. Then we can click on Add a device and select ABB third-party device and select the E-kit. Then we can add the IP address of the E-kit and the serial number, which you can find on the label of the side of the E-kit. Then we can click on Get Sub-Devices. We can select the device that we have configured before and click on Add Device. We can add the tag name of the devices that we are provisioning, and this will help us in recognize our device on the cloud. Then we can click on Update to Plant. Here we have to select on which plant we want to provision these devices. And here we are on the plant with all the devices correctly integrated. And we can then select real-time current widget and the real-time power. We can see data coming from the devices from the E-kit. Now we can wait a couple of minutes. Now we can see data coming from the devices connected via E-kit.